In this video, we'll take a bird's eye view and summarize everything we've done with inferential statistics over the past number of videos. It probably seems like a lot, but there's a bunch of similarities and shared basic ideas. The first thing you want to ask yourself when you're doing inferential statistics is, what is your purpose? If your goal is to estimate some population parameter, then you want to construct a confidence interval. On the other hand, if your goal is to test an existing claim about a population parameter, you're looking at doing a hypothesis test. Next, you want to figure out what kind of parameter you're attempting to measure. You might be measuring a proportion, which you can usually think of as a percentage if that helps. So your sample statistic is p hat, which you can use to estimate or test the population parameter p. Or you might be measuring a mean, so your sample statistic is x bar, which you can use to estimate or test the population parameter mu. Now remember that everything we do with inferential statistics depends on certain conditions being met. We always have to make sure that our sample is random, and that we can treat our sampling process as independent, often by making sure that our sample size is less than 10% of the population. If we're looking at a proportion, we have to make sure that n times p hat and n times 1 minus p hat are both at least 10. If we're looking at a mean, we can proceed if the population parameter is normally distributed, or if our sample size is at least 30, or if our data looks approximately normal when we're doing a t-test. Next, we need to figure out what kind of sampling distribution we'll be dealing with. Proportions always use a normal distribution, a z-distribution. That's why we talked about the normal approximation of the binomial distribution earlier. For means, it depends on whether we know the population standard deviation, sigma. If we do, we can also use z. But if all we have is the sample standard deviation, we have to use a t-distribution instead to account for the extra variability. Once we know what kind of sampling distribution we have, we need to figure out its center and spread. For proportions, the sample proportions, p hat, will tend to be centered around the population proportion, p. And the standard error will be the square root of p times 1 minus p over n. Or if we don't have p, like if we're doing a confidence interval, we can just use p hat instead. With means, the sample means x bar will be centered around the population mean mu. And the standard error will be sigma over root n. Though if you don't have the population standard deviation sigma, like if you're using a t-distribution, you can use the sample standard deviation s instead as a substitute. Finally, once you've nailed down your sampling distribution, you have to use it to answer the question you wanted to ask. If you're constructing a confidence interval, that means taking your estimated value, that is, your sample proportion or sample mean, and adding and subtracting your margin of error to get your range of values. That's your estimate of the population parameter. On the other hand, if you're performing a hypothesis test, you'd calculate your test statistics, your z or t, and then use that to calculate a p-value. Finally, compare that p-value to your level of significance alpha to figure out whether or not you should reject your null hypothesis.